Hello students, in this lecture we're going to start reviewing trigonometry, and the first thing we're going to talk about is angles. So angle is pretty much a simple geometric figure. It has two sides, and the vertex, this is the vertex. And this one is usually called initial side, and you usually take an arrow and you show that your angle starts at the initial side and goes to the terminal side. So this side is usually called terminal side. And for the angles, we usually use Greek letters, usually use alpha, beta, gamma, and often we're going to use theta. So theta is the Greek letter. So people usually define so-called standard position for the angle. Standard position for the angle would be you put initial side always on the x-axis, So let's try to show the angle in standard position. The angle in standard position looks something like this. So you have an initial side along the x-axis, and then your terminal side, something like this, and your angle goes this way. So this is initial side, and this is the terminal side. And again, the arrow shows you start at the initial side and you go to the terminal side. This is your x-axis and this is your y-axis. And as you can see, we move this way, but we can also probably take our initial side, put it on the x-axis over here, and put terminal side over here, but we can also move this way, right? So again, this is initial side, and in the future we're going to start right this initial side and terminal side, but it will be clear. Terminal side, and we moved in a different direction. This is your y-axis and this is your x-axis. All right, so let's try to identify this rotation. This rotation is counterclockwise. So counterclockwise is actually positive direction. Counterclockwise is a positive direction, and clockwise is a negative direction. Clockwise is a negative direction. All right. Also, we can come to the terminal side by rotating a couple of times around the circle. For example, if this is our initial side over here, and this is our terminal side over here, we can do this. We can go once and then second time and come back to this place. All right, so basically we can come to the terminal side by moving a couple of times around the circle, but as you can see, it could be done clockwise or counterclockwise. So now, since we defined angles, we can try to define sine, cosine, tangent, cotangent, cosecant, and secant. So let's try to define six trigonometric functions of an angle. So basically, we're going to define, there are many different ways to do it. Probably in school they define it a little bit differently for you, but we can think of it like this. We can take some point in xy plane and point in xy plane always defined by two coordinates, x and y, but we're also going to introduce the length of this side r, and I will explain why it's r in the future. And if this is your angle theta, we can say that sine of theta is before in school they said that sine of theta is opposite side over the hypotenuse, but for us it's more convenient to think that this side is of length y, so y over r. And cosine of theta is adjacent over the hypotenuse, which is adjacent is this side, and in our notation it's x distance over r. Tangent we can define as, so this is called sine, this one is cosine, this is tangent. So tangent is opposite over the adjacent side. So in our notation, y, which is this side over here, divided by this side, which is x. So y over x. And now we can define cofunctions. So cofunctions is cosecant of theta, which is by definition, so it's a reciprocal of sine, so it's r over y. We can define secant of theta is a reciprocal of cosine, so it's r over x. And we can define cotangent of theta is reciprocal of tangent, so it's x over y. And usually we deal with two famous angles, and they're very important to us, so let's talk about these two famous angles. I said angles, but actually what I meant is triangles. Oh, before we do that, before we define this, this is going to be our next idea. It would be good to talk about very important idea here while we're discussing it. So let's look at the main trigonometric functions: sine of theta, cosine of theta, and tangent of theta. Over here we can see that sine of theta by definition is y over r, cosine is x over r, and tangent is y over x. So in this quadrant 1, in Q1, we can see that all of these values are positive. X is positive, Y is positive, but R is always positive. It's a distance. So that means all ratios are greater than 0. If we move to this quadrant, sine, as you can see, will be positive because Y is positive. But cosine will be negative since x becomes negative over here. So here we'll have only sine of theta to be positive, but tangent and cosine to be negative. So in the next quadrant, only tangent is positive. Why is that? Because y becomes negative, so the sine becomes negative. Cosine is negative because x is negative. And tangent, we divide one negative number by another negative number, so tangent becomes positive. And in quadrant 4, sine will be negative because y is negative. Tangent will be negative because y is negative, but cosine will be positive because x becomes positive. So cosine of theta will be positive. And so the famous rule says all over here, sine here, tangent over here, tangent and cosine over here. So the rule is ASTC rule. We're moving counterclockwise because it's a positive direction. So all students take calculus, right? All students take calculus. It's not really true. A lot of students don't take calculus, but for our purposes, it's good enough. So after this discussion, we can discuss our two famous triangles. Two famous triangles. And what are these two famous triangles? One is 45, 45, and 90 triangle. So basically that's measures of the angles inside of this triangle. We know that full circle is 360 degrees, right? So our angle is 45 and 90. So how do people come up with these quantities? People came up with these quantities the following way. As I said before about square root of 2 to be irrational number, you can always build a triangle of the sides 1 and 1. And if you use Pythagorean theorem to calculate this side, it's going to be square root of 2. And that's how this triangle came up. So what do we know about this triangle? That this angle is 45 degrees, this angle 45 degrees, and this angle is 90 degrees, because the sum of angles inside of the triangle has to be 180 degrees. So let's calculate the sine of 45 degrees. The sine of 45 degrees, again by definition, let's think of this angle as 45, opposite over hypotenuse, so 1 over the square root of 2, but some people want to write it like this. You choose the way you want to write it. It doesn't really matter for me. How do you come up with this? You rationalize the denominator by multiplying both by square root of 2. Cosine of 45 degrees will be also the same because it's going to be adjacent over the square root of 2. So the same, you can rationalize the square root of 2 over 2. And also we need to define the tangent of 45 degrees, which is opposite over the adjacent, which is 1 over 1. This would be 1. Now we need the cofunctions, so cosecant of theta would be the reciprocal of this expression, which is square root of 2 over 1. Then, oh, I said theta, but I meant 45 degrees. Then cosine of not cosine, but secant of 45 degrees will be also square root of 2. And cotangent of 45 degrees will be 1 over 1, which is 1. So that's one famous triangle. Another famous triangle is 30, 60, 90 degrees. So how we can build it? We can build it like this. So this angle is of 30 degrees, this angle is of 60 degrees, and this is a 90-degree angle. And people usually take specific quantities over here. And so let's see if we can come up with this. So if you build up this triangle, if you continue it on and you connect this like this, then this angle will be 60 degrees and this angle will be 30 degrees, but 30 and 30 together will be also 60 degrees. So if you take this side to be of length 2, and then and this triangle is called equilateral triangle if you consider this big triangle. So if the side is of length 2, then this black part over here will be of length 1 because it's half of the whole side. And then if you use Pythagorean theorem to calculate the third side, it's going to be this side squared, minus this side squared. So it's 4 minus 1, and this is squared, right? So it's going to be 3. So x will be square root of 3. So this side over here is square root of 3. So if we make this clean picture, then we get something like this. This is 30 degrees, this is 60 degrees, this is 90 degrees, 1, 2, square root of 3. After this, we start writing sine of 30 degrees. So for 30 degrees, opposite is 1, hypotenuse is 2, so it's 1/2. Cosine of 30 degrees is adjacent, square root of 3 over 2. And tangent of 30 degrees is 1 over the square root of 3. But again, some people write it as square root of 3 over 3, not crazy important. This would be good enough. Then we go for cosecant of 30 degrees. Cosecant of 30 degrees is 2 over 1, so it's 2. Then secant of 30 degrees is 2 over square root of 3. And cotangent of 30 degrees is square root of 3 over 1. Now we can deal with 60 degrees angle, which is not really accurate over here. Let me fix it. So 60 degrees angle. So we have sine of 60 degrees is equal to, so this is 60, opposite is square root of 3, hypotenuse is 2. So square root of 3 over 2. Cosine of 60 degrees, this is 60 degrees, adjacent is 1, hypotenuse is 2. And tangent of 60 degrees, is, so it's 60 degrees over here, so it's opposite over the adjacent, so it's going to be square root of 3 over 1, or square root of 3, if we don't really need 1 here. All right, so cosecant of 60 degrees is 2 over the square root of 3. Secant of 60 degrees is 2 over 1. And cotangent of 60 degrees is 1 over the square root of 3. So we discussed these two famous triangles. All right, so maybe that's a good place to stop for this lecture. And in the next lecture, we'll do some examples and try to measure angles.